Hello, everyone. So today's topic of my talk is going to be GraphQL in Revolut, and it's kind of soft adoption that we have in Revolut. So I am Andrii Los. I'm mostly working on back office and infrastructure. I mean, not official in infrastructure, but anyway, I'm doing a lot of stuff there. Back office is kind of our big admin page that we have under the hood in Revolut, where everything is basically got managed by our agents and other guys who are working with us. Of course, I'm based in Krakow, Poland. We also have guys in London and Moscow and Petersburg and whatever. So without, further ado, let's go to the topic itself. So GraphQL, what it is? Yeah, so main question, how many people here are using GraphQL like every day? Silence. Okay, that's good. How many people know about GraphQL? Okay, this is good. Anyway, but I mean, since not many of the people are using it, I will, long story short, will explain in like basics what it is. Basically, GraphQL is a specification that Facebook wrote. Basically, is a technology that was made to kind of replace or add something to the rest or replace some pieces of it at the beginning, but then probably they're using everything for it right now. They use GraphQL for everything right now. So it's created by Facebook. They've been using it for 10 years right now, from what I know, because they've been using it internally from 2009. Basically, specification is made of schema definition language. Basically, what kind of resources you can get from your backend once you query it, and the query language that you use on the client side. So also specification consists of like what kind of response the server should give you, and all kinds of things like that, right? So what server should do to implement the spec, and whatever. Yeah. So basically, it looks like that. The typical GraphQL two things, right? On the left side, it's is the mouse is visible though? Oh, it's not. Okay. So on the left side, there is a schema definition language. It's this piece is on the server. Basically, it describes what kind of types backend can return back to the client, right? So we have a root. I'll go there. So we have a root thing here. Yeah, this is a query word, and this is a root type. So on the root type of query, we have three fields: me, user, and all users. Basically, it's what client can get from the server. So me will return current user, right? User accepts the argument of ID, which is required. This exclamation mark means that it's required field, and it will return user, but it's not guaranteed. As you can see, it's without the exclamation mark. All users will return the list of the users. And there's also a user type, which basically describes this user type is out there, and the a noun type out there. So on this side, we have a client query. It's a basically query language, because this is SDL, it's schema definition language. This one is that you use on the client. So this is keyword query. This is just meaningless name that you can do whatever you like here. This is what arguments this query is going to take. And here's the user, right? Basically what we have here, right? So we have user. This thing returns user. So we have an option to return the four fields from the user. But since we don't need, for example, the email, right, in our particular case, so we just basically say like, can you please give me these three fields, right? And as you can see, these fields are there. So I will just click the same thing. And under the hood, how it works, how the server basically resolves this query. Yes, so it gets this query, it parses it and whatever. Then it says like, okay, what field from the query type I need to retrieve? And it says, okay, so query type, find user, it's a stupid name, as I said. So it returns user, and the field is user that we're going to return, right? So it's the same. As you can see, they're kind of interconnected. You can see this connection between reference. Then we see the type of the user and three of these fields, and then three fields going to be resolved. So basically, the simplest explanation is like for every single field on the type, the one function is going to be called to resolve this particular field. So first of all, user will be called. We'll probably go to DAO or database. We'll get by ID. We'll get this user, and then this user will go down to the other functions that will basically resolve ID, username, and role, and that's it. So and it will be collected together and thrown back to the client. So its main features was that it's free fully typed documentation. Basically, if you have GraphQL, you have schema, means you have everything typed, and it's kind of already some sort of a documentation that should, for example, out of the box, you don't have it in REST, for example, right? Powerful developer tools. Since you have typed schema, you can do all sorts of auto-completion, lookups, and all kinds of things, just kind of for free for you. Flexibility means that you basically define all of your backend thing and the schema and whatever. And if you have different kind of clients, for example, mobile wants these 2 fields, but web UI can show many things. So he would like to show you not only user, but also his recent posts or whatever. So you can just say like, give me that, and it will just give it to you. So flexibility, you don't need to go and ask backend. They're like, can you please give me another API? Can you give me another? Can you give me this 5 attributes to filter this out because I don't need it? So many things you just don't need to ask. It will just give it. They will just give it to you. There's also ready-to-use client implementations. Since all the responses from the server are typed, they are predictable. There's already implementations of the clients for Android, iOS, web environment, and whatever that are basically will do all the heavy lifting for you about your data layer, about loading states, about I don't know, optimistic responses, about caches and stuff like that. So it's really nice and cool. So you don't need to handle it yourself. And code generation of types on client based on schema, right? So if you use TypeScript, and we use TypeScript, there's a so typical that new endpoint is created, or you have old endpoint, which was written in the back in the day in a JavaScript, and you would like to type it. And what are you doing? You go to the backend code, for example, if you don't have much of a documentation, and you will go and see what is optional, what is not, and you go back to your client-side code, and you will create the type, and like a lot of double work, basically. You will need to go check. It may probably change, then you need to go back to front end and change it once again. So here, since every single server should return you back the schema, every single server that implements GraphQL specification, he returns you back the schema. It means that once you run yarn start or npm start, whatever you prefer, it can go to the server by URL, typical development server that you have instance, will take the schema, generate the typings for you, and you're good to go. So, but it's like in the future. I'll also tell about it, how it all works and whatever. Basically, cons, I mean, team has to know how to cook it right, because it's a completely different approach. It's not like it was before, like you have REST endpoint, there's basically one function, and you do a lot of if spaghetti code to handle this request. So you need to cook it right. But basically, there is a lot of articles about it. It's not a big deal anymore. It's not like it was maybe 3 years ago or 2 years ago. The only format is JSON. Yeah, there is no option to use XML or Protobuf or whatever you like. So all answers are 200. Yeah, if you have an error, if you have whatever, it's 200. If server is dying or some like critical exception will happen, it will be 500. But rest of other answers will be 200. But it's not a big deal because you will get errors and you will see the nice error message, which is, I mean, still good. So since it's a big change, it was really hard to introduce it to do some proof of concept in the Revolut, right? So the main problems are that we have a lot of people, and you need to prove people that this thing is cool, that it will not break everything, that we will not spend 3 months on doing something that then we can throw away. That's the one thing. Then infrastructure. If you would like to do something extremely small, you still need to go and try it in production, not in something like small, stupid blog at home, whatever, that you will post on GitHub. So you need to ask the DevOps guy to do a lot of, I don't know, load balancer and stuff like that in your GCP, and it's a lot of stuff you need to do just to test the one small thing that probably nobody gonna use. You never know. Oh, and of course, it takes a lot of time and it's a lot of risks. Yes, so you want to make it as simple as possible. But and so main question is like how to keep it extremely simple, right? The simplest one solution that most of the GraphQL servers are is basically a proxy, right? You have already your own REST API. You land another proxy in between of them that will basically proxy all the requests to your typical REST API. And at the end of the day, you'll get kind of a front end for backend sort of a thing. That's the simple thing but as I said, you still need to make a server, load balancer, and all this thing, and you need to track down the bugs and what's happening and logging, and it's like not a simple task. So how to keep it even more simpler, right? So it's basically, how can I do it myself, not touching anyone, so nobody even noticed that I'm doing something. So some people who are actually working with GraphQL or know a little bit about it will say like, what the hell right now? But basically, the trick is that you can make a GraphQL server on the client. It sounds like crazy stupid. What the hell is that? And you'll say like, what? Yeah. But the trick is that GraphQL is basically doesn't really care about your transport, right? You can wrap it around your HTTP and you will go and it will do actually requests and stuff like that. But it actually doesn't really care about transport. It means that you can, if you are able to parse the query and then to execute these functions, this resolver function that I said before, you can do it on client. And since we're in JavaScript land, everything is universal. It means that you can do it on client. Of course, it will give you about 100 kilobytes of gzipped runtime. But if it's internal tool and you can experiment and no user will gonna see it, you can experiment and it's cool. So you can make everything on your client. So here on the schema is traditional approach, right? You have your client app with Apollo client, which is one of the most flexible and cool clients for GraphQL, and then you have schema and resolvers that basically communicate with other APIs. They can be GraphQL APIs, they can be REST APIs, they can be RPC, whatever, JSON API, all kinds of things. You can just like grab it all and make it one nice, beautiful GraphQL. In our case, it looks like that. You have everything on client, like just let's put it on client because we can. So you have the schema, you have resolvers, you have everything on client. It gives you a lot of unneeded runtime, but you can try things at last, which is cool. So as I said, how is it even possible? Basically, Apollo client, it's some sort of I don't know, it's just a client, right? If you're in React world, you will create a provider that will basically give you all the data down the tree, right? So it's basically client that handles and know how to talk to GraphQL endpoints. And they have things that named link. It's basically kind of a middleware that you can kind of extend this Apollo client, and you can just basically connect to do some sort of a stages, like on error, on query, or before the query. So all kinds of things like that. So there's that regular thing. It's Apollo link HTTP. It's the regular one when your actual GraphQL endpoint is HTTP. Another one is Apollo link schema, which is basically used for unit tests to actually mock up all of the resolvers on the client, so you don't actually go and call a real server and whatever. So it's kind of used for unit tests, but it appears that you can actually run it in a browser environment. So, and basically done. So you can write your resolvers that will actually go and call REST endpoints on your client, which is still will be a lot of requests, like it is. But I mean, still, that's all cool. So what problems is solved for us? So basically, our problems is that we have a lot of new people. Basically, 1 year ago in the Krakow office, we had 70 people, and in the whole company, it was 200 maybe. Right now, we have 750, and it grows like 50 people, I think 40 people every month. So a lot of new people, right? And that's not only agents and stuff like that. There's also developers. There's many old APIs we have, even though we're not very old, but there's still already old things that are not extremely well documented. I mean, unit tests maybe is still documentation we have. Problems with their documentation and problems with process of documenting of new APIs, right? At this point, you may say like, why you just don't use Swagger or something like that? Well, we can, but I mean, if I ask my frontenders like, can you please give me at last Swagger? They will say like, okay, maybe someday, because they have more important things to do, and it's internal tool. Just go and do it yourself, because they are busy with more important things. So it's not actually working very well for us, but that's why we don't have any Swagger. I think we have it, but in few very, very, very new pieces. Old pieces are quite messy, I must say. So anyway, it's like that. So it's our problem. So that's going to be a little bit of a video, basically how it solves us docs. Even though it's running on the client, we still have all the benefits of GraphQL. What is the GraphQL? It's kind of a web-based IDE where you can actually play with your GraphQL endpoint. You can see the docs on the right side and stuff like that. So basically, this is how it looks. So on the right side, you have a documentation. You can see all kind of the queries and results, like possible queries that you can do. You can search for it, and you will immediately get it. You can also see all kinds of types, all kinds of queries, what they return, what default values are, and stuff like that. Also, mutations is basically post, update, put, whatever operations, and you can also see all of the names of them, what types they return, what's going to be optional, what not, and whatever. So everything is perfectly there just by design of GraphQL, how it's done. And it actually works even though the whole thing is on client, which I was extremely surprised. And it actually works. So, and the next thing is basically, next small video is how autocomplete is working there. So you write the query, you open it up, then you see all of the queries possible, like basically autocomplete. It says like, can you please give me more fields or arguments? So we pass some arguments, for example, tab. Yeah, we have some messages by tabs, and here's the tabs. It's enum, so it's actually autocomplete says what kind of enums are there. So then you ask for fields that you want, like create date, whatever. Outgoing message, whatever. What kind of empty message is Swift? If you ever worked with Swift, you probably know what is all that means. And then it returns you back the data on the right side, and you can scroll down and see all these fields and whatever. And you can play and you can understand, basically, even though you have REST endpoint and stuff like that, which is, for example, not documented, new guy that will come in, he will go to this GraphQL, and he will not gonna ask somebody like, is this endpoint does ever exist? He'll go and he'll basically play with it for 10 minutes and he will get all the answers possible. So it's all cool and it's all nice. Okay, so, but what's main problems at the beginning that we've got, right? First of all, double work, right? It's what I've been saying, that first thing you need to go and look what the type is looking at the backend, how the type is looking at the backend. You also, and then you write down the typings, right? Right now you need to write the GraphQL schema, right? You write the GraphQL schema, and after that, you will need to go and write your types. But as I said before, I already spoiled that, you can generate it based on the schema. So the double work will disappear. Also, size of the schema grown to 3,000 lines of code in 1 month. So basically, it's basically one file. And if you're not doing any trickery, it will be only one file. And it just grows, it grows, and grows. And we've got 3,000 lines of code in one file, which was impossible to work with. Yeah, so double work, as I said, I need to type in GraphQL first, and then I need to type in TypeScript. It's not cool. I actually thought to do it myself, but then I Googled it and it was so good that it's already there. This tool is already there because I thought about reading abstract synthetic tree like Babel and stuff like that and actually generate it out of that. But it figured that it's already there, and this tool is amazing. So basically, GraphQL code generator reads your GraphQL schema and will generate not only typings but also high-order components for your Apollo. Query components for your Apollo, like if you use Apollo client, for example, on React, with React, and everything. So its setup is simple. It's basically a YAML file. You basically say where your schema is, where your documents, basically the client side things, basically the queries, the server queries, basically the schema definition are, and where you actually call it. So TypeScript files, as you can see, documents, and basically it will generate one file named client types TS6 with everything generated based on your schema, and then you call GraphQL gen, and it will magically generate something. For example, out of that, it will generate your typings on the right. So at the left you have client. So we've got our enum in TypeScript. We've got our find user variables, basically user ID that we have there. We have find user query, which is basically find user, and it's a query, so it's find user query that returns user of type maybe, which means that user may be there, maybe not. So it will generate for you. And if it's like that, it's not beneficial, but it's 3,000 lines of code. It generates you 7,000 lines of TypeScript, which is so cool. So you basically end up with thing that names schema-driven development. So you've got new feature. So okay, it's basically next slides. So you've got the schema, right? So you've got the new feature. You fill in you kind of describe the new endpoints in the schema. Then you basically, after the schema is done, you code generate the types for resolvers. Basically, this resolver functions, what kind of arguments they have, what they should return for resolver functions. Then you generate, you make resolver implementation. You finally code something. Then you write this client queries. Basically, how are you going to use this data basically on your client? Then you generate types for these queries, because every single query will have 3 fields, other will have 5 fields, and for every single particular query, it will generate a separate typings. So basically, you implement the view, and you're basically done. Yeah, so it's kind of schema-driven development. You do changes. So in case of changes, it will look like that. You do change to the schema. For example, backender says you that this field was used or it was renamed. You said like, okay, it's all cool. I'm gonna do the change. You go, you change the schema. It regenerates automatically because it's in watch mode, just listening to it. It regenerates the types. Your website, your compilation, TypeScript compilation, or it's getting broken, or everything is fine. If everything is fine, you're good to go to ship. It's all good. But if compilation is broken, means something breaking change happened. So you need to actually go and fix it, right? So you fix this compilation errors. You're done, and it's basically endless spin, right? So what about this huge schema grow, and how did we solve that? Again, I thought that I will need to do something special and whatever, but again, I Googled it for 5 minutes and I find out amazing solution by the same authors that created this code generator from GraphQL code generator, which is named GraphQL modules, which basically does the trick for you. So you can split everything by the domain. So you have, I don't know, you have a transactions, you will create a domain that will be related to transactions. You have some business-related stuff, you create business-related stuff like user handling, whatever, authorization model. So you will just extract it to the modules, you will extract the schema, you will extract the resolver functions that will basically implement the schema, and other stuff like that. So it's basically really cool stuff. I'm not going to dig into it because it makes no sense, and we don't have time. But it's just simple as hell. You have dependencies, you import things one to another, and you completely can see all the connections between the modules and stuff like that. So it's really cool. And it works out of the box with Apollo server. So basically, what our future? The future is in the back office. I mean, in our environment in Revolut, the future is to actually extract the client server to a real node server, because for a real server, there's still way more tooling. There's still way more possibilities. It's not, because the current implementation sometimes is weird and it's not completely working perfectly as you expect it to work. But I mean, quite stable. I mean, something happened extremely rare, and usually it's not a big deal. But the real one will work nicely, cool. And it's not only we will be able to use it only on our side, on the client, basically, but some other clients will be happy to use this a real server, because it will be like you can use it everywhere. So wide adoption at back office, because right now we have, I don't know, maybe 5 or 6 features that was written completely from scratch using this new approach with this GraphQL thing and Apollo client. So more wider adoption. So not only me and 2-3 other guys will be happy with it, but most of our developers on the back office will be happy with that. So after we will extract, we will adopt it, we will have some best practices, we will be able to easily extend it to the other projects, not only back office, but maybe others that we have. And maybe the best thing that will happen if we will implement that in native Kotlin Java GraphQL server. That will be amazing, but I need to prove this, guys, and it's extremely complex. Almost impossible, I must say. But anyway, so basically summary. We prove concept, GraphQL developer experience in production. So we know how to use it right now on client. We hit a lot of walls. We solved these walls, and we feel like it feels way better than it used to be. So we learned a thing or two. We improved our docs significantly, because right now, yeah, things are way better in this case, especially old pieces. We improved development speed and developer experience once again, because if I was doing this feature, I left, some guy come in, he goes, he sees this what kind of resources are available. Everything is nice and clean for him, and he will continue work on the stuff way faster than it used to be. That he will, again, probably will go on the back end, will try to find something on Confluence, on some documentation and whatever. So we found a lot of bugs, but it's probably not about GraphQL, but more about TypeScript, because we got adopted it like 7 months or 8 months ago. And we found a lot of bugs once we typed our legacy endpoints. We found out like, oh, we've been looking for the field that never exists here. And it was like many places. But fortunately, we've been checking. So at last, it's not undefined or something. So in next steps, probably stuff will get even better if we will implement the things that I said in the future, like Kotlin and stuff like that. So that's basically it. You can ask me questions. I will gladly answer them, because I think we still have 18 minutes. So I got faster today. Yeah.
I've got one.
Yeah.
So I see some potential in using GraphQL when you have like a multiple APIs that you need to talk. So you just build this proxy and then just route your way around. But what if you actually have a single API? Okay, behind this you can have like a microservices architecture and so on and so on. But if you have like a one gateway, isn't it better to actually, I don't know, maybe some kind of go through the code, generate Swagger from that, and then do other stuff than throwing a GraphQL on top of that?
It depends, of course, like as everything. Actually, if you don't have anything like Swagger and stuff like that, maybe it makes sense to just make this proxy, because it improves if you have a complex application. Because right now our benefit is not extremely big. Why? Because on admin page, we're not much we're not much doing this client side caching, because it's a sensitive data, and if we see transactions, we want to see these transactions like the freshest one. We don't want to keep the cache just to do fancy save like one request. So it's not actually beneficial for us, because our client, we don't do any caching. So, but if you have a complex application that, for example, on every single change, you would like to update some other fields around your application, it will require you a lot of ad hoc code that you have on your client. Apollo client, this GraphQL client, actually handles all for you. So if you, for example, do mutation and you do this change, it will return you back entity of the same ID. It will update it everywhere on the client, and you will not even touch. You will not even move a finger for that. So it's a lot of benefits for clients, because it will be clean what is available, what is required, what is not. Also, it generates you types. So you see that you're not just like put everything optional because you have no idea what's going to be returned, right? You can really reduce all your if checks and stuff like that. So you can program more, not safety, like because you know that it will be there. So it's all cool, but it depends on what kind of application you have. In back office, actually, we're actually pretty fine with REST and stuff like that. But the biggest struggle is documentation. So, and since we do also TypeScript migration and we need to type everything, I decided like, why should we already doing typing? Why we just also create this proxy that maybe some other guys will benefit from it in the future, maybe. So I decided that it would be nice to make it on client, to test it all out, and then to extract it to proxy to actually get all these benefits of documentation and stuff like that. Also, what is good, if your server actually returns back a null for a non-nullable field, it will blow away. So it's also good for duck typing. I mean, so you're like, I have no idea. Let's put it like as required one, and it's null. Okay, so we can just make it optional, and then you get it optional on your TypeScript code, and you actually fix the bug for sometimes, or like you do additional security if check. Like, okay, good, this thing can be optional. So I mean, there's a lot of benefits. I mean, what I've been describing here, just like simple things to get documentation and try fancy stuff. But for cool apps like Facebook and stuff like that, when you have extremely deep nested graph and connections between the data layers, with REST you will need to do 4 or 5 calls, for example, or you need to go to ask backend guy to actually create, like, are they connected even? Here you can see all the connections between the data. So it's basically go back and forth one to another. So it gives you a lot of freedom, but of course, with a lot of freedom, it gives a lot of responsibility, of course. But again, you can also solve that by complexity. You can put the directive of complexity of the query So it will calculate the complexity of all. If you'll do something extremely nested like recursive, for example, and say like your complexity is over limit, like 200 complexity, and it will say it will not execute this query at all. So you will be like, okay, yeah, I'm probably stupid, and you'll probably rewrite it in a different way. So I mean, there's a lot of other things that makes it like way above and way better for Swagger. Swagger solves you only documentation problem. That's it. GraphQL solves many others, and for some people it's just so good. So they like Atlassian using it, Facebook using it, Airbnb using it. Who else is using it? GitHub is using it, and many of other people like Medium is using it. So many of the companies, PayPal, like I can just probably remember a lot of them, remind all of them. So I mean, it's not that simple thing. It's nice to go and dig, and client is just heaven and earth basically for clients. For backend, it's a learning curve, of course, because you need to know how to cook it properly. Yeah.
Do you have experience with GraphQL and Redux? Because I heard that GraphQL can save you much of code for Redux.
Yes, that's the main point, because if you have a Redux, right, it's a kind of global state, if somebody doesn't know, for your client app. And basically, like 90% of your state in the Redux is basically what you just fetch it from your backend. And you usually use probably Redux Saga, you're using Tank and stuff like that to handle all these loading states and caching and all kinds of complex things that you can do with this client-side stuff. And with Apollo and Redux, in Redux you can keep only your global client state. For example, UI client state, basically models, notifications, and maybe something that shared across few components, and that will be nice to have. For example, routing or something like that. But all the data is basically got outsourced to the Apollo client. So you can just completely remove about, I don't know, in case of back office, that would be probably around 10,000 lines of code, maybe like 5,000 lines of code, because we have some generic approach and sometimes we write ad hoc code. But 5,000 code we can just basically remove, because data layer will be solved for us. Data layer will be solved, and we will have maybe only 3-4 reducers for models, maybe, and for the notifications, and probably routing. Yeah, that will be 3 things that we'll have. Right now we have like that huge tree with all kinds of data in it, and it's just annoying. So yeah, that's actually typical combo. It's Apollo client plus Reduxer plus MobX or plus context API of React, because it's also good right now. So you can use it for these 3 small things pretty well. Something like that. And we have Redux. Yeah.
Do you have any unexpected problems when you are writing resolvers?
So far, not. I mean, the first question people are usually asking when they say like, okay, you have every single field you get the function call, right? And it's maybe not performant, right? Because for example, a very common example is that, for example, you fetch the list of posts, and also posts are having author, right? And you would like to get some information of the author. And of course, you have a feed of, I don't know, and since, I don't know, you have like 5 people working on some Times New, for example, New York Times, right? And there's like 5 authors. And probably few of them will be the same. And if it's like the most stupid implementation, it will call even though author, for example, was the same for 5 posts, and 5 in every single post there was the same author, it will go and take this author from the database, which is like, no way. I mean, it's probably way until you have a high load, and it's stupid. But there is approaches that there is things that basically gives you ability. It's named Facebook Data Loader. There is also implementation for Java for that, and for JavaScript, basically that gives you ability to, after every single function, to go and do kind of lookup, so to create a cache. So basically for a query. So basically it will be a context of your query, and it will go fetch thing and then look up to the data loader. Is something is there, and if there is a user in the same ID, it will just grab it from there. So it's just simple approach. So, and it basically solves everything. It's like one thing, so it's at last do find by ID once. But another thing is that you can optimize. If you see that one query is extremely heavy, you have a name of this query. And if you don't have any public API, it's another story. But if you have only like your internal API and you don't have any public one, you restrict it to the name and some hash of this query, and you see that this is extremely heavy, and you would like to optimize it. So it's not do the stupid queries and then whatever joins without the joins. And you can just say like, okay, just make joins and stuff like that out of these arguments in the top, and it will just resolve it in one function like you do with REST, for example. So if you would like to optimize some heavy path, you can always do like 20% that are heavy. You will go and optimize. It will be basically one function call like in REST, and it will do optimized, joined, cool, amazing, manually written SQL query. But for all others, 80, for example, like profile page, like people are going to the profile page not very often. If it just works with this optimistic, just keep going, not a big deal. But for something heavy, you can just always optimize. And people are always think like, oh, it's a performance. No, like Facebook, I mean, heavy loads, Facebook probably they do have heavy load, and they're completely fine with that. So yeah, and I think I will add another slide. Right now it's not added with the URLs to the interesting articles and whatever stuff. So once it will be shared, I think it will be shared, you'll be able to go and read it. So because there's some amazing ones. Any more questions?
Here.
Yeah.
So it looks like GraphQL is pretty good, like to query content. But what about using GraphQL to modify data, like the equivalent of doing posts?
Yeah, there's mutations that I said. This is basically the same thing as you have post, put, update, whatever. Basically, everything is post in GraphQL. Yeah, you basically create a mutation. You have an argument, and you have a function that is going to be called. The only thing that it will be not on a query root type, but a mutation query type. And it will do the trick for you. It will basically grab these arguments and will call this function and will return back something that you actually put as a return type. So no magic, no magic basically here. It will go change some data. And what is cool that if you design your GraphQL endpoint properly, you can also in the same query ask whatever you like from the, for example, you can return the query root type, for example. Then you can query whatever you like from your regular query type, and it will go and basically give you everything you want, and it will update your stuff, and it's just like so powerful. But it's just advanced use. And in these articles about design and stuff of your schema, you're just reading about it. It's like, oh, it's even cooler than I thought because there's many things you can do, especially in the case when you have complex APIs and you would like to things updated everywhere. So yeah, mutations is there, it's working. Also, there's a subscriptions for the things like WebSockets, right? So if you have some data that needs to be updated over time, you have a listener, you put it on a subscription, and it will automatically, pipe in some more data like after something is coming, for example. Something like that. So yeah, there's changing, no problem. But with files, you may get tricky, but yeah, not a big deal. Still solvable, as I said. Any question? Yeah.
Because you mentioned WebSockets, do you think is it good to use WebSockets with GraphQL to maybe notify about kind of big data changes, like to send much data with WebSockets, or it's more about notifications?
No. You can make, it's like WebSocket, he returns you JSON, right? Like events happened, you get some data. So it's the same thing. Event happened, you get the data, what you described in your subscription. It will give you only 4 fields, for example, out of the whole type, for example. So, I mean, it just like works the same way. It, under the hood, I think, is good old WebSocket. So not a big difference. I mean, you can use it. You can use the query. You can use subscriptions. You can hold the query. You can do whatever. I mean, it's extremely flexible. So, yeah. So I think probably it is, but you can ask me anytime. Anyway, any question, we'll be happy. So, should we wrap up? Yeah. Thanks a lot.